developments in the space industry and advances in cloud computing are presenting opportunities to improve people's lives at a pace and scale not seen before. From mapping poverty to improving food security to responding to disasters, these developments could accelerate progress on each of the United Nations' 17 Sustainable Development Goals. Hello and welcome to another episode of Analytics Inside, where we dive deep into the technologies reshaping industries and our world. And I'm your host, Priya Dialani. For decades, access to high quality space data, whether it's satellite imagery, remote sensing measurements, geospatial insights, was limited to only government agencies or a handful of elite research institutions. But today, as constellations of low Earth orbit satellites generate petabytes of data every day, there's an urgent need and also a unique opportunity to democratize access to these data sets and make them meaningful for businesses, scientists, and even local communities around the world. It will take artificial intelligence, however, to unlock this potential by turning the skyrocketing amounts of space data into actionable insights for the world's decision makers. Let's welcome Rupesh Kumar, CTO and co founder Suhora Technologies, to travel far beyond our atmosphere into the incredible frontier of space data and the transformative role of AI and machine learning. Hi Rupesh, how are you doing?
Yeah, thank you, Priya. Thank you having me here. And how about you?
I am doing good too, thank you. And it's a pleasure to have you with us on a podcast today. I think our conversation today is going to be very special. I mean, I am particularly excited to talk about it because space is something that I'm always been curious about. So I think we will probably get to know more about space and, of course, the role of technology as to what we can do and use technologies in multiple ways to make use of space data and probably improve our decision making, key decision making that could probably impact our lives and make it more better. So before we dive deep into our our main agenda and conversation, let's kickstart by telling our listeners more about Sohora Technologies. So if you could help us understand more about the organization, its specialization, it would be great.
Sure. So, Suhora Technology was founded in 2018 by myself, Krishanu Acharya, and Amit Kumar. We are based out in Noida, and our core idea is simple space analytics simplified. So, not be limited to the big infrastructure institutions and scientists, but it should be empowered to everyone. Our main goal is, if you will see our logo, we have put it the space analytics simplified. Means the space data is the very complex data. You want to simplify all the data can be accessible to every common man and can be understandable to every individual. So this is our aim. So our main specialization is making satellite data accessible and useful. You do this through our platform called the Spade. The Spade platform, meaning of a Spade platform is, I think, quite a bit complex. I will just explain about. So, our platform for the advanced data exploration. So, what does it mean? Because today, if I talk about the satellite data can be the various types, like the optical, thermal, then SAR. SAR is called the synthetic aperture radar, then RF data, AIS data. These are the kind of data that is going to be collected and received from this satellite into the Earth. So optical data, if you want the data into the daytime, then optical is the way. If you want the data 24 by 7, day and night, any weather, then synthetic aperture radar, that is the radar data, is the one of the option. The thermal data is very interesting today to get the deeper insight from the data. Is if you want to extract some thermal anomalies inside the particular area or into the building, the thermal data can be helpful into the any weather, anytime. RF, if you want to recognize some kind of the object, then RF can help it out. So I'm just going to light about our Spade platform. So a Spade platform is the multi-sensor integration platform, which is going to enable the people, they access the data anytime, anywhere, and they can also the task the data from the satellite. In nutshell, I can say this is just like the joystick for the satellite. As for example, if you want the data for the day after tomorrow or next 7 days, you need the particular area, let's say example of the Noida, then you can just draw your AOI and you can just see the based on of your various option you have chosen, the which type of satellite is going to be orbit in next 7 days. As for your way, you can just select the any kind of the satellite constellation satellite and click on the order button, and that satellite is ready for you to collect the data. Once the data will be collected, then you can just download the data easily into lower bandwidth as well, because we have applied the various compression algorithm into it. And on top of it, because the satellite data having the some processing to understand the insight of it, the on the fly through our platform, you can just check out the which type of value-added services you needed. You can just click on the button, our AI algorithm just extract the information and provide the data to you and insight to you. This is the SaaS-based, subscription-based model. Any person can access this platform with the very minimum cost to start with the $5,000. Our mission is to break down the complex satellite information into clear, accurate insight that drive decision making across the various industries. We are essentially bringing the gap between the raw data and the practical business application. So, all about our company and about our Spade platform. Apart from this, we have the two more platforms that is called the Mirka and Seed. Mirka is especially designed for the national security and defense, and Seed is for the disaster management and insurance sectors users.
Great. That's an insightful and detailed overview about Suhora, and I'm so glad to know about that the company's mission is very simple, simplifying space data, space analytics, and making space data useful and accessible to everyone, and making some effective use out of it. So I think that was pretty much missing, considering the today's era where everything is evolving so fast, and even the role of technology is advancing each day. So let's dive a bit deeper into your personal journey and contributions to Sohara. You have over 17 years of expertise in defense and space application, and your work focuses on advancing Earth observation satellite applications, remote sensing, and AI-driven analytics to enhance national security, disaster management, and commercial space initiatives. So, can you tell us more about yourself? How has your journey been till date? And what triggered, how Suhora technology was born?
Yeah, thank you. So, actually, Suhora Technology is founded by the three of the co-founders, myself, Amit, and Krishanu. So, I am from the software development background. So, I having the experience to developing the various mission critical application using the space data and remote sensing. The another co-founder, Krishanu Acharya, he is from the sales and BD. He, he has the vast experience to work into the various worldwide satellite company. He understands more about the data and the requirement about the end user and sector. And Amit is from the operation. He is also having the more than 16 years of experience. Then he services the worldwide to the various MNCs. So as a CTO and co-founder, I wear several hats, but my prime focus is on our technology, strategy, and keeping innovation at the center of everything that what we do. On the technical side, I design our core platform architecture, lead our AI and machine learning efforts, and work building the algorithm that can harmonize the different kind of data, different source of the satellite data into the one consistent view. I also make sure our platform is scalable, reliable. So as more customer and the data come in, it just keeps working. So because the scalability and easy to use, and the customer can engage in our platform and they can solve their problem with the minimum steps that we are keeping into the mind while developing of any product and ideation of the any idea. So from an innovation perspective, I can say I help forge partnership with other technology leaders and ensure we are always exploring the next frontier, like integrating the cutting edge AI tools and technology into our existing technology ecosystems. And also strategically, I spend time growing our technical team and fostering a culture where the people feel excited to experiment. So, in our day to day life and in our company environment, we are providing 20% time for their experiments and R&D. So, because R&D is the prime focus for the any uh, tech related startups who is working on the futuristic idea. I also represent the Suhora at conferences and the forums, the sharing our visions, the making satellite intelligence truly accessible.
Great. Thank you so much for sharing that, Rupesh. And it's always insightful to understand not just the what, but the how behind someone's journey in a company. And of course, your hands-on approach to steering innovation and your experience with software development really is shaping the direction of the company. And it's also helping us understand how the company is adopting and evolving in a rapidly changing environment. Now, moving ahead, thousands of satellites are being launched every year on the back of advances in technology and a diversifying space industry. And among the more conservative estimates, Euroconsult expects 2,800 launches annually through to 2032 to meet the growing demand for global connectivity. Now,
Yeah.
Earth exploration and a space exploration, there are a lot of things that come into picture. And as in numerous other industries, operators are using AI to address the dynamics of busier orbits. So, how is AI enhancing space data analytics, and how Suhora is leveraging AI in their workflows?
Yeah. So AI has really changed the game in satellite data analytics. Even I can say that all the ecosystems of the satellite industry. Let me just tell more about the space industry. So space industry has been divided into these three segments. The first is the upstreaming. Upstreaming, the all about the all the satellite that is existing into the orbit. Mid and second is the midstreaming. Midstreaming is nothing but the ground station which is just going to connecting with all the satellite into the orbit. And third one is the downstreaming. Downstreaming is nothing but the how we can extract the insight from the various complex and large amount of data and provide to the end user the actionable insight. So AI can utilize into the various way in our industry. In past, interpreting of the satellite imagery was slow and very manual process. But today, AI helps to solve the three big challenge in the space data analytics. First is the scale. Satellite generates the terabytes and petabytes of data daily. AI algorithm can scan all the data to spot the patterns and object detection instantly, because the AI algorithm is just going to extract the patterns. Let's say if I give you examples, if you want to identify the change detections into the various assets into the ground like the buildings, so AI algorithm just going to extract of the building's footprints in a minutes. Manually, it can be take the hours, days, or weeks. So this is the one of the examples. Also, it can be utilized into the various sectors like agriculture, environment protections, urban planning, disaster management, national security, extract, etc. So second I can say about the speed. Machine learning model can process the incoming satellite imagery in near real time, which is critical for the application like disaster response, monitoring the asset on the ground. Third is the accuracy. AI can combine the data from the multiple heterogeneous sensors like the optical, synthetic aperture radar, then SAR imagery, thermal imagery, and the hyperspectral imagery together to create the richer insight and picture in depth. At Suhora, we are enabling the AI in every major steps. For example, we use the algorithm that automatically classify and tag the imagery for the various specialized use cases. Our quality control filter out the cloud coverage or the low quality data so user only can see the best result on the ground. Pattern recognition model can detect the subtle change in the terrain or the infrastructure over time. And we are working on the predictive model that will forecast the trend, not just the so what happened, but it will guide you the what which type of action has been taken in the futures. So this is all about Suhora and how we are adopting the AI in our all the workflow.
Great, that's incredibly insightful, Rupesh, and thank you for breaking that down so clearly. Of course, what really stands out is how Sohora is not just using AI as a buzzword, but it is corely embedding it deeply into the space data workflows. And I think in future ahead, we of course need more scalable and intuitive insights and how we can shift our mindset from the space tech industry and make it into a full intelligent action approach. I mean, it's truly the future of geospatial intelligence unfolding right in front of us. Moving ahead, I think when we are talking about space data, I mean, space is so good at generating data sets. Data is definitely the key. But how can we make space data open to everyone? I mean, not just open data, but giving people the tools to use it to improve lives. Now, perhaps the most famous AI applications in NASA's Mars rover, now including spacecraft operations and onboard data processing, the space agency is estimated to have spent around $233 million on AI applications between 2020 and 2022. So, can you help us understand or walk through us a concrete example as to where AI driven insights from satellite imagery or sensor data has helped probably organizations with more faster and accurate decision making?
Yeah, sure. So let me share the real world example like for flood monitoring work, right? Traditionally, flood alerts rely on heavily on the ground-based sensors and the manual reporting systems that often are meant to delay of the 16 to 12 hours before authority could act. With the AI-driven satellite analytics, we changed that our model learned from the historical year flood patterns, combine them with the topographic data and the rainfall predictions, and process the live satellite feeds and provide with the near real-time actionable insight. That will be very helpful for the any decision maker the ways sitting on the top. They can instruct our field workforce the where to take action first and where to next, right? So if I talk about the various examples into the other sectors, so AI can be heavily utilized into the agriculture sectors for identifications of the crop patterns, their growth, and also can be identified for the disease inside the crops. So this is one of the area. The also in agriculture, the industry is adopting the AI technology for the crop yield estimation because this is very important for to know the yield of the various crop into the particular area location wise. So AI and satellite data is helping it out. Satellite data can be utilized into the urban planning as well. Satellite data is utilizing into risk mapping as well. If you want to monitor the, uh, I can say, the moisture content on the ground, then satellite data today utilizing for accessing the moistures across the country or districts or very large area. Also, satellite through satellite data, you can identify the air quality index. Even also you can identify the air quality as well. So various area where the satellite and AI is utilizing to getting the information, the where manual process is taking lots of time. The result, the response time was cut dramatically. Alerts were out within an hour. Coverage extended, monitoring large regions that previously had no sensor. Accuracy improved because the systems continuously learn from each new event. So this makes a direct impact on how quickly emergency team could prepare and protect the communities. So these are the examples about how the satellite data and AI can utilize together.
Right. I think that's a very, the examples that you stated or the use cases that you have mentioned, those are really powerful. And it really brings to life how data, when harnessed effectively, can become a game changer, especially in critical scenarios where timing and precision are so important. And I think what stands out here is not just the speed of insight, but also the quality of the decision making. I
Yeah.
mean, clear that AI isn't just about automation, it's about empowering a deeper visibility, faster action, and in many cases, more equitable outcomes. I think while we have discussed some of the use cases and how we should be accessing space data and the role of AI. Traditional computing models, I mean, they relied on transmitting raw data to Earth for analysis, and increasingly unsustainable due to bandwidth constraints, legacy, and power requirements. Now, these were certain, I think, challenges or limitations that I would talk about traditional computing models. And I believe processing and analyzing this petabyte scale of satellite imagery is very intensive and costly as well. I mean, you just don't need advanced algorithms, but you also need a very robust cloud infrastructure and edge computing capabilities to deliver real-time results. Now, for many organizations, investing in such infrastructure alone is prohibitive, highlighting the importance of partners like Suhora that offered AI-powered analytics platform as a service. So, what are some challenges in processing and analyzing a large-scale satellite data in real time, in near real time?
Yeah. So absolutely, cloud and edge computing are game changer when it comes to make the space data accessible to more people faster and accurate. So I think cloud as our command center, it's where we store the massive volume of data and run complex AI algorithm. The beauty of it is the scalability. You don't need own server, own infrastructure in-house. You can reduce your capex. Even a small organization can process the large scale of satellite imagery. Then there is the edge computing. So this is like having a mini brain closer to where the data is collected or used. So edge means the end. So end user can get the and more accurate and faster insight of it. So it lets process the data near ground stations, even in the fields. This cut down the delay, reduce the bandwidth cost, and gives user faster access the critical insight. At Suhora, we design a hybrid setup. The heavy processing happen in the cloud like the AWS and Azure, and the regional edge nodes gives the faster access locally. We also use the microservices and API first approach, so our data can plug into other systems, other legacy systems easily. All of this makes the experience seamless, responsive, and scalable. So user can focus on the insight, not on the infrastructure and complexities of the data. So these are all about the what we are doing that. So uh, uh, I would like to add more things like our cloud processing, the heavily AI ML computation and data storage on the AWS. Edge deployment, the regional processing near nodes is giving the access and the fastest insight to the end user. And microservice architecture is going to be giving, I can say, the liberty to plug in into the any kind of the existing legacy systems of the end user. This is all about what we are doing into the AI cloud plus edge computing.
Great. Thank you for giving that insight into the technical and operational hurdles and, I mean, and it really highlights the complexity behind what seems on the surface like just a seamless stream of satellite insights. And also, I mean, thank you for helping us understand how Sohora is leveraging AI, edge, and cloud. I mean, that's very important because we need to keep pace with the growing demand for the real-time geospatial intelligence. So, just one last question for you, Rupesh. I mean, all domains are special. Space and time, however, are special in how they cut across domains. Now, they are the glue that help us organize the knowledge around, about the world around us. I mean, we may be interested in events like landslides that appeared within a region to mitigate future risk, or we may be interested in events that happened during the same time but in a different region. Like country specific social distancing measures to probably we saw that to slow the spread of COVID-19. Now, with space data capable of observing almost any point on Earth, questions of how and when data should be used or who owns it are becoming more urgent. I mean, forward thinking companies in the industry are recognizing the need for transparent data governance framework. So, innovation doesn't come at the cost of privacy or misuse. So, what frameworks or policy do you believe are needed globally to enable the responsible use of accessible space data?
Great question. So, as a satellite data become the more accessible and powerful, we have to use it the responsibility, and that means the building the smart policy around it. So, there are three big area where need a strong framework. The first is the data sovereignty and privacy. Countries should have the clear rules on what kind of satellite data can be collected over their territory and how it can be used, especially the high resolution imagery that could improve the individual privacy. So in India, in space and NRAC is the organization. These are the extended wings of the ISRO. They are taking care about all the data policy and data privacy and space policy rules. Technical and security standard is the second point. So we need the global norms on the encryption, access control, and API. So ecosystem says secure and interoperable. So third is the ethical regulatory framework. We have to think about the dual use risk, where same data could be used for good or harm. Also, environmental sustainability matter, especially with the growing number of satellite and debris. International agreement like the Outer Space Treaty and update to reflect the today reality, including the private players and commercial data sharing. At Suhora, we believe in the open source and ethical access to data with the transparency built into the everything we do. So these are about the framework and policy from my side.
Right, definitely. And I think what's clear is that a space is no longer the domain of few superpowers or a multinational corporation. The democratization of space data powered by AI is bringing life-changing insights to communities, businesses, and researchers who once lacked access. And of course, companies like Suhora are at the forefront of this movement, bridging the gap between raw data from orbit and usable intelligence here on Earth. So definitely, I think we stand at an incredible inflection point. Thank you so much, Rupesh, for taking out the time and effort to be on a podcast today and helping us understand that by weaving AI into the very fabric of space data analytics, we have the chance to build a more transparent, responsive, and informed society, one where insights from one orbit are accessible to everyone, helping us better manage our planet's resources, respond to crises, and unlock opportunities for growth in every sector imaginable. Thank you so much, Rupesh. It was lovely chatting with you.
Thank you. My pleasure.
Great. So, this is for our listeners today. That's all for today's episode of Analytics Insight. And thank you for joining me as we explored how AI is enabling universal access to space data and the profound ways it can transform our world. If you enjoyed this conversation, don't forget to subscribe, leave a review, and share this episode with your colleagues. Until next time, keep looking up and keep innovating. Thank you so much.